Welcome to Uni, What? Today we will learn about the different combinations of resistors. Let's start without wasting any more time. There are two combinations of resistors. 1. The series combination. 2. The parallel combination. Let us now look at them in detail. 1. Resistors in series. When resistors are joined from end to end, it is called in series. In this case, the total resistance of the system is equal to the sum of the resistance of all the resistors in the system. Pay attention to the diagram and we will derive the equation from it. Let 3 resistors R1, R2, and R3 get connected in series. The potential difference across A and B equals V. Potential difference across R1, R2, and R3 equals V1, V2, and V3. Current flowing through the combination equals I. We know that V equals V1 plus V2 plus V3. According to Ohm's law, V1 equals IR1, V2 equals IR2, and V3 equals IR3. Let total resistance equals RS. Then, V equals IRs. From the equations we just derived, IRs equals IR1 plus IR2 plus IR3. RS equals R1 plus R2 plus R3. When the resistors are connected in series, the current flowing through each resistor is the same and is equal to the total current. Let's do a question to understand this concept better. Study the electric circuit shown in the diagram and find 1. The current flowing in the circuit and 2. The potential difference across the 10 ohm resistor. Pause the video to work out the answer yourself. The 10 ohm and 20 ohm resistors are connected in series. Their equivalent resistance is R1 equals R1 plus R2 equals 10 plus 20 is equal to 30 ohms. 1. Current flowing in the circuit I equals V divided by R or 3 divided by 30, which is equal to 0.1 ampere. 2. Potential difference across 10 ohm resistor. To find this we know that V equals IR, which is equal to 0.1 multiplied by 10, which is 1 volt. Now for resistors in parallel. When resistors are joined in parallel, the reciprocal of the total resistance of the system is equal to the sum of the reciprocal of the resistance of resistors. Let 3 resistors R1, R2, and R3 be connected in parallel. The potential difference across points A and B equals V. The total current flowing between points A and B equals I. Currents flowing through resistors R1, R2, and R3 equals I1, I2, and I3 respectively. We know that I equals I1 plus I2 plus I3. Since the potential difference across R1, R2, and R3 is the same, which equals V according to Ohm's law, I1 equals V divided by R1. I2 equals V divided by R2. I3 equals V divided by R3. Let total resistance equals to Rp. Thus, I equals V divided by Rp. Then, V divided by Rp is equal to V divided by R1 plus V divided by R2 plus V divided by R3. Or, 1 divided by Rp is equal to 1 divided by R1 plus 1 divided by R2 plus 1 divided by R3. In a parallel combination, the potential difference across each resistor is the same and is equal to the total potential difference. Let us now do a question. Find the current flowing through the electric circuit shown in the diagram. Pause and do work it out yourself. Now here the series combination of 1 ohm and 3 ohm resistance is in parallel combination with a 6 ohm resistor. Their equivalent resistance is 1 divided by Rp equals 1 divided by 6 plus 1 divided by 3 plus 1, which is equal to 5 divided by 12. If 1/Rp is May 12th, then Rp is 2.4 ohms. Now, resistors consisting of 3.6 ohms, 2.4 ohms, and 3 ohms are in series, their equivalent resistance will be Rs equals or 1 plus or 2 plus or 3, which is 3.6 plus 2.4 plus 3, which is equal to 9 ohms. Hence, the current flowing through the circuit is I equals V divided by R. Substituting the equation, we get 4.5 divided by 9 or 1 divided by 2, which is 0.5 ampere. That's it for today's video. In the next class, we will complete the chapter by learning about heating effect. See you, and don't forget to subscribe. It's way easier than physics.